I'll be talking about the data quality and how to ensure it in your data pipelines. But first thing first, let me introduce myself in just a few words. I'm a senior cloud solution architect, and also I'm a consultant. I have over 13 years of experience with the cloud. Actually, I work with the cloud since the beginning of my professional career. And last 5 years, I work as a consultant. I'm involved in diverse projects for clients from various industries and working with all three major cloud providers. And lately, I've been primarily focused on GCP. I always like to say that I'm a platform as a solution services enthusiast, because I just like the concept of just taking the service, deploying it, and starting using it. All right, so in today's media industry, data isn't just a byproduct. It's the lifeblood driving content decisions, marketing strategies, and audience experiences. Executives are flooded with metrics and report, but the real question is, can we trust the data? So without clean, reliable data, even the most sophisticated analytics can lead companies astray. Inaccurate or inconsistent data can lead to false conclusions and therefore poor decisions. I think if you are on the executive layer in the media industry, you all know it best. I just reply here what we encounter with our customers. All right, but what exactly the data quality is? While building data pipelines with our customers, we always focus on these 4 principles, and these principles are widely recognized in the industry and frequently referenced in the literature, and those are best practices working with the data. So first of all, accuracy and consistency, because of inconsistent metrics, teams may waste time debating whose data is correct instead of acting on insights. Let's say two departments reporting different view counts for the same show, right? You really need to avoid those situations. And high quality data systems ensure everyone is looking at the same numbers as a single source of truth. Next, we have a completeness, which is, in other words, for media firms, it may be a full view of audiences and the content, like a 360 degrees view. That means capturing all the relevant events, every play, pause, click, share, advertisement, impression across all platforms. If the data is incomplete, if important pieces are missing, decisions are made on a partial information. For instance, if a platform fails to log when viewers stop watching a show, the content team might miss signals of disengagement, right? You would like to avoid those situations. Next, we have another pillar, which is timeliness, because real-time or fresh data is incredibly valuable. Trends come and go in hours. Outdated data can lead to missteps, like promoting yesterday's news, right? So ensuring data is delivered quickly and consistently means decisions are based on the current reality, not last quarter's snapshot, right? And finally, validity and relevance, because data must also be in the correct format and actually relevant to the business question at hand. Modern pipelines include steps to validate the schema and filter out the noise. Incoming data must match expected formats, have all the required fields that will be analyzed later on, and this pipeline needs to discard extra fields that aren't useful. This prevents garbage data from polluting analysis and ensures focus on meaningful information. Also, it's just as a bonus, you get the FinOps, because if you store less data in the cloud, you pay less for the storage. So again, you know it better because you're from the media, but investing in data in data quality is investing in the ability to complete and innovate. It's about empowering your analysts, AI models, decision makers with with information they know is correct. Now, let's see how we can architect a solution on Google Cloud that delivers high quality data reliably. The idea consists of 3 services available on Google Cloud. First one is Apache Kafka for real-time data ingestion and streaming. Next, we have Google Cloud Composer for orchestrating workflows and automating data processes. And finally, we have Cloud Dataflow for scalable data transformation, enrichment, and quality checks. All right. Let me move to the next slide. Apache Kafka, I think, is a service that needs no introduction, but for those of you who may not know it, Apache Kafka is an open source distributed streaming platform designed for high throughput, low latency, and handling of real-time data streams. It enables applications to publish and subscribe to stream of records, store them durably, and process them as they arrive, acting as a central event bus that decouples data producers and consumers, which will be important in the later steps. And one important note here: streaming refers to continuous real-time flow of data, known as data stream. I know that from media companies, streaming may mean that we are talking about streaming videos like Netflix, but here, when I will be referring to streaming, I'll be meaning real-time flow of data. So,
Chris, sorry to interrupt. Can I just ask if we maybe revert to the previous slide, because I thought it was really interesting, because I previously heard of Kafka historically. I was going to ask here, has it got any features built in that can actually improve the quality, the data quality, if you like?
Yeah, this is very important questions, because I'm praising some features. I'm presenting my solution for the data quality pipeline, but none of the features, none of the services will handle this quality out of the box, right? Every feature it's very important to understand that every feature enables us as a architects, as a developers, as a data engineers to implement steps to provide the data quality. So thank you for this question.
Yeah, all good. Thank you.
And getting back to Kafka and its features, it's very popular and it's an industry standard, I would say, because it's built to be fault tolerant and scalable. Kafka clusters spread data across multiple servers and use replication. So even if one machine fails, your data is not lost and the system keeps running. So the design ensures messages are processed efficiently and reliably in large-scale environments, right? And Google Cloud also offers a managed service for Kafka, which is preferred in my scenario, which handles much of the ops and maintenance overhead. All right, so maybe we'll consider a scenario regarding the Kafka. Let's say a streaming video service wants to log every play, pause, rewind, or even a rating in real time, right? To understand user behavior. With Kafka, each of these events is sent immediately to Kafka topic as it happens. The events are durably stored in order, forming a chronological log. And downstream systems can tap into the stream at their own pace. Nothing's get lost or skipped. Kafka can handle millions of events per second. In fact, Netflix uses Kafka to ingest the enormous stream of events from viewing habits to application interactions. So Kafka's ability to buffer and retain data means that consumer can always catch up. Consumer meaning the following service which will proceed with the data. If a processing job falls behind, Kafka holds the data until it's being processed, preserving completeness to our data quality pipeline. That's why I mentioned that this service decouples producers of events from the services that will do the data analysis. And finally, from a data quality perspective, Kafka helps to ensure completeness and timeliness of data. Completeness because every event that occurs can be captured, and timeliness because it enables streaming data instead of waiting for a nightly batch, right? As data flows in, it's not enough just to capture it. We need to process it through various steps to ensure quality and get into the right destinations. So this is where Cloud Composer, Google's cloud managed Apache Airflow service comes into play. Remember, managed meaning no or less maintenance is required, less ops overhead for development team. And Cloud Composer acts as a conductor of your orchestra, scheduling and coordinating the various tasks and jobs that make up the data pipeline. And the data flow enables creation of workflows, which are called DAGs, meaning directed acyclic graphs. But usually you just call it a DAG. All right, and how does Cloud Composer enhance the data quality efforts? So first, by enabling the pipeline to include explicit data quality checks and validations as a first-class tasks. For instance, you might have a task that runs data validation script on the output, checking for anomalies, or enforcing business rules, like this field needs to be present, it mustn't be empty, or ensure yesterday's record count matches expectations.
So, Krzysztof, can anyone actually, use that, or who's using Airflow? Can they actually use that with your actual idea here?
Yes. So, as I explained, Cloud Dataflow is Google's implementation of open source Apache Airflows. So, if you already know Airflow, you know it from your on-premises data center, or maybe you hosted it somewhere else in other cloud. You can take your knowledge and use it in GCP. Or if you have your workloads on premises and need more compute power, you can move your workloads to the cloud. So I think that implementation of open source service is really great for this cross-platform compatibility. All right, so Cloud Dataflow, Cloud Composer, and also can ensure that issues are caught early and do not after a faulty report goes out. So if Kafka is our real-time data firehouse and Composer is the conductor, then Cloud Dataflow is the engine that performs the heavy lifting. The heavy lifting of data processing and transformation. Cloud Dataflow is Google Cloud's fully managed service for running Apache Beam pipelines, capable of both batching and streaming data processing. Again, on the beginning, I mentioned that I'm a platform as a services enthusiast because I like to focus on job done rather than on a cloud maintenance. So here is a third service, and it's a third managed service. So this would be the environment that I would like to work with. So Cloud Dataflow is here that we can actually clean, transform, and enrich the raw data, applying the rules that ensure quality and making the data analysis ready. And again, let me get back to the separation of data producers and data processors. If Kafka buys you time, Dataflow buys you elasticity, right? You can do a lot with the data here. Yeah, and the use cases where the data flow can be applied. So let's start from the schema validation. I know that Composer can also do it, but here we have even richer experience of a schema validation. So if a message arrives at the data flow pipeline, it can be immediately validated against a predefined schema. So this step ensures the data was in the correct format and met expected standards. Also allowing to catch any malformed records early. Next use case is filtering and field selection. So the pipeline filters out unnecessary fields, right? Keeping only the data that are relevant for the analysis. For example, out of hundreds of attributes in the log file, perhaps only 65 or 13 are essential for the business needs in that use case. This does not only simplifies downstream processing, meaning less noise in the data, but also means analysts won't be distracted or misled by irrelevant data. And also, as I said earlier, helps us optimize the cloud storage bill, right? So it's an important step for maintaining relevance, focusing on quality data that matters, not just the quantity. Next, we have the duplication, which is quite self-explanatory, but it's a critical quality step to remove any duplicate records, right? Duplicates can happen for a various of reasons. A producer retries a message, or a user action logs twice by a mistake. If it's not addressed, duplicates can lead to overcounting. Imagine counting one viewing twice, which would skew up the metrics. Next, aggregation and windowing. Dataflow pipeline can group the streaming data into the time windows, for example, 5-minute intervals, and compute aggregates within each window, such as the count of events, sum of watch time, etc. This is more of a analytics steps than a cleaning step, but doing it in Dataflow with proper windowing ensures that even in a continuous stream, you'll get a consistent time bucket metrics for analytics. All right, next, enrichment. In many cases, Dataflow can also enrich the data by joining with reference data. For instance, adding metadata to a content ID, like a title or a genre, by looking it up from a BigQuery table or from API, or tagging a user event with a segment or location by referring a CRM system. So this ensures that data delivered to analysts or machine learning models is not only clean, but also rich with context. And finally, we have error handling. In many cases, the data flow can also enrich the data. If any record failed processing, say it couldn't parse or violated a rule, Dataflow can route those to a separate error output for logging or for a later review by a developer team. All right. In summary, all of this happens automatically and continuously in Cloud Dataflow. Remember that those are not out-of-the-box features. You still need to configure it, develop it, but the result is a stream or a batch output of quite high-quality analytics-ready data. Right, worth noting that Dataflow can also send the processed data into a BigQuery in a near real-time manner, where the business intelligence team can query up-to-minute insights. All right, and we have a summary here. So by leveraging Google Cloud technologies like Apache Kafka, like Cloud Composer and Cloud Dataflow, you can build a modern data infrastructure that guarantees your data is timely, accurate, actionable, and this pipeline is the digital supply chain of your organization insights. And finally, you benefit from cloud features like high SLA, managed solutions, pay-as-you-go billing. Thank you.
Thank you, Krzysztof. Really, really informative there. I may need to go back for my bedtime reading to go through some of that, but I think we've all learned a thing or two. So like Chris before, quite busy in the questions. We've got a few lined up. I can see David and Amy have asked some questions already. Normally I go ladies first, but in this case, David did ask first. So how does Kafka Dataflow architecture scale during sudden audience spikes? Now, he gives an example here, like a live sports final, without degrading stream quality or blowing up costs completely. What do you say about that, Krzysztof?
Yeah, that's a great question. So the short answer is each service scales independently. So you can rely on Kafka to absorb the shockwave, right? The huge spike of events, and it's up to the organization, up to the customer to decide whether we can wait for the data to be processed, or you would like to scale the data flow to handle those events in near real-time manner. So remember, we have two types of scaling. We have a horizontal scaling, when cloud is adding instances of a service to handle like a more connections, more events, and we have a vertical scaling, which is adding more power to a service. So if there's a live event, Olympics, a race, it is possible that Kafka may be scaled horizontally, meaning adding more instances to absorb the incoming traffic, and maybe you would like to scale the data flow vertically, add more compute power to do the counting in real time.
Great stuff. I think we got that one there. So I'm just going back to Amy. Thank you for that. So how do we expose clean revenue critical metrics, so like eCPM and fill rate, to partners without letting them reverse engineer, for example, our user level data, Krzysztof?
All right, so it will depend by a customer, I would say, but as far as I know, eCPM is a metric that requires some counting. So maybe so probably Dataflow can handle it, and then output the data to some storage, and a third party would query the data from the storage, or even we can tell Dataflow to send the data, post the data to some other API. So it's doable. That's why Dataflow is there. It really depends on the specific scenario there.
Gotcha. I think that's really, really clear. Right, thank you so much, Krzysztof. Really helpful stuff.